Hi everybody, so in this video we'll see how show bits function work. So we want to print the binary representation of a decimal number, okay? So the decimal number here is 39. So if I run the program, it prints the binary representation of this decimal number, which is 39, right? This is the binary representation of 39, which has been printed using this function show bits, all right? So so normally when we want to convert a decimal number to binary, right? So I will take 39 and I'll divide it by 2 and uh, so so I'll get 19 and the remainder will be 1, and then I'll again divide it by 2. So 2 into 9 is 18, which will throw a remainder 1, and then 2 into 4 is 8, which will again throw a remainder 1, and then again I'll divide 2 into 2 is 4 and the remainder is 0, and then 2 into 1 is remainder is again 0. Okay, so 100 and then 111. This is binary. Okay, and 39 is, yeah, so this is the binary representation of 39, right? So we can implement this in C, but a more efficient way of achieving this of achieving this will be using AND mask, right? So what we do here is we start a loop. So you can see the representation here is 8 bits, right? So we'll start a loop from I is equals to 7, okay, and we'll take it all the way to 0, and then sorry, it's not less than, it's greater than equals to 0, and then I minus minus for each. Um, so it will decrement till it reaches 0, right? And and then with and then with each iteration I'll store this I, and then I'll create an AND mask, which is I'll shift 1 by j bits. So for the first time, so let's say at first iteration j is equals to 7, okay? So if I shift 1 by 7 bits, it's 1 and then 7 zeros, all right? So let's say, so one of the use of AND mask is to check whether a bit is true or false, right? Suppose I pass a bit 39, right, where for which the binary code is for which the binary code is 001001111 okay, that's the binary code for 39, right? So if I that's the binary code for that's the binary code for 39, right? So if I want to check that the seventh bit is 0 or not, I will simply multiply this. Let this decimal number be n, and I'll simply perform a bitwise AND with AND mask. So if seventh bit is on, that means if seventh bit is 1, right, it will return 1, or if the seventh bit is 0, it will return 0, right? So 0, 0, 1, double 0, and then triple 1, all right? So if I take bitwise AND of both these sequences, I'll get 0, right? So 0 for all so 0 if I take AND of both these numbers, because the bit was actually 0, right? Now let's say we want to check this one. This is the fifth bit. This is a 7-bit, 6-bit, fifth bit, right? So if I want to check for fifth bit, so here it will be 0 and 765, right? So rest all of them will turn 0, and this one will be and this one will be 1, right? So this value is something, but it's not 0. It's a non-zero value, right? So when it returns a non-zero value, when we take a bitwise AND of n with uh, AND mask, if it returns a non-zero value, that means this bit was on. That means the fifth bit was on. That means the fifth bit was 1, right? So that's exactly what we'll check here. If k equals to 0, it should print 0, right? Else it should print 1. That means if it's a non-zero value, it should print 1. Okay, so that's exactly what we have implemented here in showbits, right? I have taken the I'll pass the unsigned I'll pass the unsigned character inside showbits, right? So here, so n will be the decimal number, and then the loop will start from 7 to 0 because 0 to 7 is eight bits. Here the representation is using eight bits, and then j is equals to I, and mask is so and mask is equal to will shift one. So we'll shift one by the number of bits we want to check, right? So if you're checking the seventh bit, one will be shifted by 7 times, and k is equals to n into n mask, right? So n will be so n is the number which we have passed in the function, the decimal number and this and mask, and if the product if k is a non-zero value, it will print 1, and if it's a 0 and if k is 0, then it will print 0, right? So if I so let's say if I pass so let's say if I pass 32 here, then it should print the binary sequence of 32. That's exactly what it is, what it will print. 001 and then 5 times 0, because that's what 32 is, right? So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. So 1, 0, 0, 0, 0, 0. Okay. So that's what 32 is, and showbits will print the binary representation of the decimal number passed in the function.